a few other things as well. Okay, so this was one of the questions that was where we needed to work out the mean. And again, with something like the mean, um, you can and you need to find you've got about a week and a half to decide which is the easiest for you. Calculator, any calculator. So you don't, it's not exam room where they check which calculator you use. You can use any calculator, if it is a programmable calculator, if it's a scientific calculator, financial, doesn't matter. You can use any calculator that you want, and you are also allowed to use Excel. Okay, so something like this question, I would have done in Excel because, just again, I haven't used a calculator in in really a long time. And then what Excel also allows you is, if there was a bit of other questions around this that may be focused on the mode or anything like that, you can use it as well. But in Excel, what I would have just done is, and I will make it bigger after I just type in the numbers. You could have done exactly the same with a calculator, where you would have said just 12 plus 14 plus 11 plus 16. You can go that route, or you can go the route where the calculator has in the built-in capacity to look at x's and y's, and you could have just have it that 12 is x1, 14 is x2, go that process as well. So whichever one you're most comfortable in. So there's 14 numbers. So if we wanted to get the mean, remember the mean and average is exactly the same. We would have gotten, and let's just make it bigger. I will share the spreadsheet with you as well, but we would have gotten 11.07. They said round it off to 1. So 11.1, there was the 11.1. But also, let's just add a few things for you. So that is mean, and we can look at mode. So mode would have just been, and there is a mode function. Mode would have been 12, and median is the other one that we want to look at. So already, if you look at those data points, you can already see mean, median, and mode are not the same. So your data is not going to be symmetrical. There is going to be a bit of skewness in it if that was anywhere another part to this question. Okay, so And what you can see, and this might happen in the exam, is the median we said, I think, was 11.5. Okay, so what can happen in the exam is the mean was asked for some of you, there's the answer. The mode was asked for some of you, there's the mode. And the median was asked for some of you, and there's the median. So one question with just three different outcomes, and some, and that's why it's important nearly not to try and say to somebody, well, I've got option A for my first question, because your first question could have been A for the mean. Somebody else might have said, needed to say C because it was a mode that they asked, and somebody else they asked for median, and there is the median as another option. Okay, so just again, nearly reiterating, but use nearly what what's the most effective or quickest for you as well, because mode to median, I don't think any of the calculators have that function, got the mean, but not that. So mode, one that happens the most, you can identify by looking at it. Median, you would have needed to order. So you could have gone the Excel route just to order the data. And then out of that order, that would have been your first 6 numbers, or 7 numbers, sorry, that's your second 7 numbers. So you can see that between 11 and 12, that is where your your median is, and your median is between 11 and 12, it's 11.5. Okay, so you don't need to also always know the Excel functions. You could have just ordered the data, look at how it is ranked, and see that then between 11 and 12, that is where you basically have your median. Okay, so I just wanted to show, I will add again this to the overall or booklet or Excel spreadsheet that I will share again after the session, as I update that spreadsheet with some of the comments. Okay, then there was, I think, this one, the standard deviation. So let's quickly put this as mean, median, then do this sheet as standard deviation. And let's quickly look at the data. 117, 105, 120, 107, 120, 124. Okay, so let's do a few things around this also in Excel that you just have it. So here we're talking about standard deviation. So let's first do, before we get to deviation, let's first do sample variance, then population variance, then sample standard deviation, and then population standard deviation. Okay, so let's just, then again, you have it when you're working on the data set. Okay, so when we look at sample variance, there is a function. So variance S basically is the sample variance. So that's your sample variance. Let's just look 59.5 was the, look at that, 59.5. So again, that's your sample variance. So again, this question could have been structured as one question in the exam with some of you that needed to work out a sample variance. If we work out the sample standard deviation, there's two ways that we can do it. It's the square root of sample variance. Let's just check how many. Okay, so they go to, so there's your sample standard deviation. So it goes to 2 decimals. So let's just do that. So that's for one way, is to go from your sample variance, square root it, but there's also standard deviation of sample that would have taken that into account, and you will see you get the same answer. Okay, the difference between the sample and the variance is in the formula. So the, not sample and variance, sample and population. So your sample is where you have the sum of those, n minus 1, where you divide by n minus 1. Population, you just divide it by n. So my assumption would have been that is your population variance, and this is probably your population standard deviation. So let's quickly check. So exactly the same data, we go to variance, then we select the one that looks at the population, same data. Oh, smaller. Oh yeah, because it's divided by a bigger number, 49.58. 49.58. Okay, so that is not, so let me quickly take, just want to, no, I was going to delete everything. Let's do undo, undo. Okay, let's do it that way. Okay, so that was then probably the odd one out. And then if we look at population standard deviation, again, one can do it two ways. The square root of that. Wow. Oh, wait. I was now thinking, how can that be? Okay, 7,04. Okay, so there it is, 7,04. The standard deviation of your population. And we can just also do it from a standard deviation point of view, that we're looking at the population from that formula, and we will also get the same. So again, we'll share the spreadsheet that you guys have this access to as well. So again, very important what you need to work out, because there's, again, like in one of the previous ones when we looked at mean, median, and mode, for each of them there was an answer. Here, if I ask any of the samples, so variance of a sample or standard deviation of a sample, there is an answer. If I ask you the population standard deviation, there was an answer. So just very important to note that. Okay, so let's see what else in last week's session we didn't cover, that we just go into the detail. So this we covered in detail, but I know, let me quickly check what was the question on the WhatsApp group. Just want to see what I needed to explain again in this. So just quickly, will it be possible to do a question where they asked to prove that A and B are independent? So we need to just want to make, so let's do it for this data. So let's do it a bit differently. So I'm gonna we're gonna copy this. And the question was, if you need to prove that A and B are independent. Okay, so let's go to this data and let's say I want to know if Malawi and business is independent. Okay, so how they will probably ask it is not straightforward, but we need to work it out. And phew, I spelled that terrible, but independent. But I think it's more around the process, how to show it. So remember, to show independence, you need to show that probability of A times probability of B is equal to the probability of A and B. Okay, so that is what you need to prove. So if those two are similar, then those two variables are independent. Okay, so what's the probability of Malawi? It's 37773 divided by that total. And I made a mistake. So what I now actually have written down is the probability of Malawi and business. Okay, so that's what I actually have written down. Okay, so probability of Malawi is 198,807 divided by that. And it shows you how quickly one can make. And then the probability of what we said business is 215,703 divided by 20044.425. Okay, so if that answer is similar to the ant, then we know that it is independent. If it's not similar, it's dependent. So 198,807 divided by 2004425. So that is 0,0992. We need to multiply that with 215,703 divided by, again, 2004425. 1076. I will change the landscape or the slide now that one can see all of that. So 992. So if I do that, if somebody can just check, my answer is 0,0107. So if we say 3777 divided by 2004425, that answer is 0,0188. Okay, so very close, but not exactly the same. So these two are not independent. Okay, so that is how you would have shown the independence or not. Okay, so on this type of data, this is how you will be able to do that. Then the other one that is very seldom in a table, I think we saw it in one of our other preps, is if, let's say, this number wasn't there and it was 0. So whenever there's a 0 in a table, that will then actually mean Zimbabwe and business, because it's a 0, it's mutually exclusive. Okay, so it's not, so if there's a 0 in a table, it's not because it's a mistake. It then just shows that there is no people that is, say, in that country and that visa type, which then means that it is mutually exclusive. So whenever you see in a data table a 0, it's different if it's a blank, because then they probably want you to complete the table. But if there's a 0 in the table, it means a 0, and it then means that those two variables are mutually exclusive. Okay, so let's go back to this one, and let's see what else we can look at. that we haven't worked out. Okay, so again, let's quickly gonna again go to Excel. There is no function in Excel to assist you with discrete probabilities. Okay, so there's no function, but one can use Excel like you would have used the calculator just to make it simpler for you to work out. So because I also want to include in this for you the the variance or standard deviation if I ask that. So let's just make that bigger again. Okay, so one thing that you will always remember if you look at the total probabilities will always equal to 1. So that's just a quick thing to check that something wasn't excluded. But then to work out the expected value, it is the 1, the x times the probability. And then for all of that, you will need to work out the sum. So it is just the sum of those. And that was 1 point. Okay, let's just take that one away. The 1.6, and I think that was hopefully the correct answer. 1.6, but let's also check if we needed to work out the variance in X. Okay, so variance in X, and now important if you guys can remember what is the formula for that. So I can remember it is your X minus the mean, hope that is correct, times your probability. So anything else, I think I'll just check now, but let's first X minus the mean. That means also, let's just anchor it. And that times the probability. Okay, so wait, probability is sitting there. Okay, so can that be everything? No, because that sum will be equal to 0. So we missed that. We needed to say somewhere we needed to square root it. So let's quickly just make 100% sure what that formula is. So variance for discrete, I'm just quickly doing a Google search. That minus that to the power of 2. Okay, it's like all other means that we normally would do. Okay, so it just means that we need to add 1,84. And let's just check if there is an option of 1,84, because that then could have been, okay, so there you see that's the variance, that's the mean. Let's just check again. Is that minus that to the power of 2 times that? Okay. Okay, so there's your variance. So again, they could have used in the exam the same set of data. For the one group, they could have asked you to work out the expected value. For another group, they could have asked you to work out the variance. And let's see if there was a standard deviation. Standard deviation is always just the square root of the variance. So that would have been 1,36, which I don't think there is. Okay, so that is not there. Okay, so, but that is how, again, you would work it out. Very difficult to work this out if you're not using Excel or your calculator, because then you need to remember, okay, first, this was now easier with the mean is to do that sum, but when it comes to the variance, it does become a long process. Okay, that we did look at Poisson. We looked at how to use the table. This one we looked at. Okay. So this was again one that we did not go into fully, that we needed to look at a bit. So let's look. The length of stay of tourists visiting South Africa from China is normally distributed with a mean of 14 days, standard deviation of 3. Calculate the probability that the length of stay of a randomly selected tourist visiting South Africa from China is at least 8 days, so more than 8, because 8 or more basically. So when we look at that, your Z is going to be, and normally write big or equal to, so 8 minus 14 is minus 6 over 3. So what is that? Big or equal to minus 2. And so we know that is 0. Let's say that's minus 2. Bigger or equal to. And so this already, just by drawing this, we could have said, okay, we know, again, this size is 0.5. So we're adding something to 0.5. So it's going to be bigger than 0.5. So not B because that's smaller, not C because that's smaller, not D because that's smaller. So if you still don't know how to use the Z table, you basically had 2 options to pick out of and not 5. Okay, so now we can go to Z table, and one can do 2 things. You can go and say, well, that the bigger area, so I can actually go to, and let's first get the Z table. Can't do it with aren't that. And just please don't. I know now I quickly Googled um, something, but in your exams, don't don't open more what do they call it? Browser windows, because that is what the iris will pick up is browser windows. So don't go and now try and search for on the web for something. Um, it's fine if you have your PDF of your study guide like this available because you're allowed to use that. But when you go on the web, it is going to flag that, and then through the exam process, they will pull that video and try to see what you did. Okay, so here we see. Let's take that away at 2. Um, so we were looking at Z of 2, 0,9772, 0,9772. What you could have also done is to say, okay, I like working with a negative table. So let's see what is negative 2. Just see, it's just weird. Negative 2, so let's quickly check. Negative 2, 0,0228, 0,0228. So 0,0228 was there, but that is for the smaller area. So if you want to get a bigger one, it's 1 minus 0,0228. Okay, so again, in the exam, could have been that the question was phrased as the tourist visiting South Africa from China is at most 8 days. If it was at most, then it would have been the probability would have looked like this, smaller or equal to. Then it would have been, sorry, it's 3. Then it would have been Z smaller or equal to -2. And that probability would have been 0,0228. Okay, so it might have been that again, they have this one question and they phrase it in 2 different ways for you to answer it in the exams. Okay, so let's look at another one that we needed to do. Okay, so let's highlights as I thought. Interesting how it highlights certain things, other ones just a small area. Okay, so let's just rewrite this in some of the. Okay. don't worry. Okay, consider information previously. So now, okay, so this was the one where we needed to work it out a bit differently. Okay, so consider the information from a previous question about the tourist length of stay being normally distributed with a mean of 14 days. So that stayed the same. Standard deviation of 3 stayed the same. Let x be random, and we will need to work out that x. But suppose that the local tour guides exceed their sales projections when the length of stay of 40% of tourists visiting South Africa is at least X number of days. So probability of X bigger or equal. Okay, so they give us that hint. So let's use that hint. And so they give us that hint. And so if they give that hint, we use it. Okay, so we know that bigger or equal somewhere here is gonna sit 40%. Okay, the 0.4. Okay, so Z is going to be just, it's going to be bigger than 1, but 40% is sitting in this space. So what is left in this area? If that is 40, what is left in this area is 60. So I'm going to look for a Z that covers on my positive table 60%. So I'm going to look for a Z, and let's make it a bit bigger. On my positive table, here we want it to cover 60%, because that area is going to be 0.4. Okay, so 60%. Okay, so here we've got it in between those two. We've got 60. So do we take 0.25? Let's see, 0.25. Okay, so let's first take Z as 0.25. It's a very small Z. Okay, so look at that. So 0.255. So they wanted us actually to take the one in the middle. So 0.255, but look at that answer. So the small answer that I originally said, yo, it should be wrong, that was actually your Z value. So if they ask you to work out the Z value, there was your Z value actually as one of the answers. Okay, so Z 0.255, and that is equal to x minus 14 divided by 3. So 3 times 0.255. 255 times 3 is 0.765. That is equal to x minus 14. So I'm going to take 14 to the other side. So then 0.765 plus 14 will give us the value that we're looking for, and that is 14.765. 14.765 is option D. Okay, so use this information to actually draw the diagram. Then you don't need to still think, oh, at least more than, is it this side, is it that side? They're actually given us that so that it makes it simpler for us to put it into the way that we need to work it out. Okay, so let's go to the next one. Okay. Standard error is basically your standard deviation divided by your square root of your sample. So let's see, there's the sample 20. So it's gonna be comma something because I'm dividing by square root of 20. Normally this would be the mean standard deviation of 12. Okay, so 12 divided by square root of 20 gives me 2,68. 2,68 grade is, okay, I don't know how they would, you get to some of the others. Yeah, let's quickly, I just want to see, no, not have a clue how you get to the others. So basically, remember standard error is your standard deviation divided by square root of n. It might have been if you said 100 divided by that or something. Yeah. Okay. So let's see here, standard error of proportion. So first we need to find out what is that proportion. So tell manager interested in the experience of long stay guests found that 16 out of 80. Let's just, I don't want to work with fractions, so let's just get that, it's 0.2. So that's simpler to work with. 0.2 times 1 minus 0.2 is 0.8. That divided by the sample size, it's in there, it's for 80, and we square root that. Okay, so 0.2 times 0.8 is 0.16. It is 0.16. So if you only multiply that out, there's the answer. If you divide that by 80, you get 0.002. Not the answer. And then if you square root that, you get the answer of 0.0447. 0.0447, which is your answer that you're looking for. So again, just be wary in the exam. Very simple to start off, and you're so excited to see there is a number. I know I've done it a few times. You're so excited, you see your number, you're like, yes, got it. Then realizing, ish, I needed to work out more. Okay, so unfortunately, they do put in some of those things in to make you choose the wrong answer. Okay, let's look at question 17. Here it was about you need to work out confidence intervals But the most important thing about the confidence interval is my population standard deviation known? Okay, so is that known? If that is known, we use a Z. If it is not known, we use a T. So depending on that. So simple random sample. Okay, they tell us it's a sample. That's still fine. But when they tell us, okay, we're going into a sample mean, that already is telling me, okay, they're not talking population mean. And then they say sample standard deviation. Okay, so population standard deviation, it's unknown. The sample is known, but not the population. So we need to work with the T. Okay, so if we then work with the T, we need to know what the degrees of freedom and what is that confidence interval that we're working with. Degrees of freedom is, I don't know why I said 4, so let's just say degrees of freedom is n minus 1. So let's see, n was 30, so degrees of freedom is 29. Alpha, we're working with 90, so alpha was 10%. 0.1 divided by 2 is 0.05. So that is the T that we need to get from the table. X is the sample mean, so that stays 110. Plus minus the T we're going to work out. The standard deviation is 21 divided by the sample, the sample of 50. And so that is what we are working out. We need to get the T. And so let's go back to this one. Let's see where's the T distribution. T distribution, we set 29 and 0.05. T 29, 0.05, 1.6991. Okay, so 1.6, and let me just check again, 1.6991. 1.6991. Okay, so 21 divided by the square root of 50, that gives us 3,8341. Gonna multiply that by 1.6991. Let's just see what we're gonna plus minus. 1.6991. 6, hope it's right, 5144. Okay, so 110 plus that on the top side, we get 116.51, and then to the bottom of it, we get 110 minus that is 103.49, and which is then option B. if, let's just check, if we did Z of 90 would have been 1,645. So 1.645 times 3.8341, 6.3071, so plus 110. And so if we did Z, there would have been the answer for you. You would have gotten option E. So again, just showing that, and it's small difference. What is it? 0.2 difference. But that 0.2 difference made it if you chosen B or E. So it might then be that you get 1 or 2 points in the exam if you chosen E instead of 4 or 5 points. Okay, so that's just, again, the importance of identifying the population standard deviation or sample standard deviation. Okay, let's go into, so here it was, again, confidence interval, but this was a nice one. It's proportions. So we have the 16 divided by 80, which was 0.2, that I remember from the previous one. Then Z, we're working with 95% confidence interval. So your Z is 1,96. So that is, whenever you've got a Z of 95%, 1,96, it's like in the previous one, I could automatically say if this was a Z, it was 1,645. So there's those three that I just remember. It is in that table in your study guide, but I remember the 95, the 90, and the 99 one, because that's the only three that they will also ask you in the exam. They're not going to ask you a weird confidence interval. Okay, so let's quickly check that and just make sure that the sample. So 0.2 times 0.8 was again 0.016 divided by 80. We're actually working out that standard error again, if I'm not mistaken. So 0,0447. Okay, so we're using a bit of that information. Sorry, squeezed in here. So 0.2 plus minus 1.96 times 0,0447, which is 0,0877, and that will then give us, lower one is 0.2 minus that, and let's hope there is an answer. 0,1123. 1123. So it is at least, oh, there wasn't answer selected. And then to the top is 0,2877. Okay. Interesting. I didn't realize there wasn't answer selected for this one. Okay, so that is what we would have done in this instance. Just again, proportion is always Z. that you use 95% is for 1,96. Yeah, so that is how we would have done with this one. Question 19. Okay, so now we go bit again into study unit 9, hypothesis testing. So they've asked us here is a few things that you could have been asked. So let's first look at critical value. So let's look at what one of our local tour guides is convinced that tourist length of stay is 14 days. In a sample of 20, the mean length of stay was found to be 15.6. Okay, so assume population standard deviation. So that's cool. Population standard deviation, we're working out a Z. So population standard deviation is 4.4 divided by the square root of n, which was 20. Okay, so we basically working out a Z. And so the first thing that I'm picking up here is where is the negative? So let's quickly, okay, so I've made a mistake here. This is now not, it's now hoping that that doesn't happen. Okay, so then let's rather, if it doesn't, wait, just okay, it doesn't erase everything, but at least it does a bit. Okay, until I remember how to do it. So 15.6 minus 14. And so that at the top is 1.6 divided by 4.4 divided by square root of 20. Nine. So the first thing that we're working out is the Z. So that is 1,6262. So that is your that is your T-stat. Z 1.6262. There is that first one. Critical value. Let's quickly see critical value. Where is the level of significance? 5%. So is it one tail or two tail? There's now a lot of scribbling going on here. Okay, so you guys tell me, is it one tail or two tail? So to me, it seems like it's a one tail. So if it is one tail, my critical value here is 5%. This side, it's 95%. So let's actually first go and check this out on the Z table. So remember that whole area is 95 because it's a one tail. So let's quickly go and look at this on the Z table. So Z, this now needs to be 0.95. So let's see, 0.999595. There's, okay, so in between 1.64, 1.65. So in the middle, and that's why we would normally say 1.645. Okay, so your Z for 5%, one tail, 1.645. Okay, so you guys can also have gone and check in other table that is in that study unit. If it was two tail, then suddenly that becomes 1.96. Okay, because then that portion in your tail needed to be split, so that would have been then 2.5%. Then you go to 97.5. If we go to 97.5, 97.5, you see it's 1.96. Okay, so just, and there wasn't a 1.96, but just by the difference between one tail or two tail makes that your answer looks quite different. Okay, then p-value is linked to this one that you worked out. So let's round it off to 1.63. So 1.63, 1.63. So now instead of going to the positive, I want that small value. Let's go to the negative table, minus 1.63, 0, 1, 2, 3, 0.0516. So let's see, 0.5, what did we say, 0.0516, and if we round that off, 0.05, okay, I would have said 1, but, oh wait, 16, sorry, oof, erase it, erase it, let's just do that. So if we round that off 0.052, so there is the p-value as well. Okay, so we've identified the critical value, we've identified the t-stat, and we've done the p-value in this one. And we're not going to ask you all three in the exam, unless it is the critical value is this, t-stat, p-value, or is it v is free or v is free or v is free. But we're not going to ask you click the critical value, click the t-stat, click the p-value. Okay, so there is the three things that we worked out. Okay, yeah, question 20 was also one that normally they would just ask you to work out the critical value, because in the critical value, you in any case need to work out the degrees of freedom. So chi-square, contingency table, 5 rows. So we can just say 5 minus 1. Let's see how many columns, 4 columns, 4 minus 1. So that would have been 4 times 3 is 12. Okay, so there is your degrees of freedom. So with that, okay, let's quickly, before we move to population standard deviation. Okay, so that is how you would know that you're working with a Z and not the T. So always when there's population, okay, proportion, it's always a Z, but here population standard deviation was the reason why we went to use the Z. Okay, so always look out for that. Even though they talked about sample year, but when they said a population standard deviation, so that is the key. Always look for, do they tell you if it's a sample standard deviation or population standard deviation? And so that's the key that you're looking for. Okay, then the alpha here, let's quickly, they need to tell us, okay, 5%. So we're working degrees of freedom of 12, alpha 5, and okay, let's just close that one now. So let's go to chi-square, 12, and it was 0.05, and there we have 12, 0.05, 21,026, 21,026. Okay, so just by working out the degrees of freedom, getting that 5% level of significance, then critical to go to your chi-square table, and that then is 21,026. Let's just, for interest sake, check. So there's a 23. I can't think, yeah, there wasn't a 23. So the others, 2219. So maybe if we did not say, but if we did there 51, so that also, so again, not always sure how one gets to some of the other numbers. Okay, so, but that is on the chi-square, basically going to, so that is important if you look at the sample size, but the most important is to look at population standard deviation or sample standard deviation. So that the population standard deviation trumps nearly whatever the sample size is. Okay, so and it's good that you ask it, because normally, and with all the work we do as well, is that when you get to small samples, your standard deviation is a bit dicey. So that's why they brought in that rule of, if your sample size is less than, then you need to use a T, but they tell you what your population is. So then you can, if you know your population standard deviation, then you're happy. Because when you know, it doesn't matter about how big my sample is, my population standard deviation is a known. Then you don't worry about actually the sample size. But it is important that when your sample is less than 30 and they don't mention population standard deviation, then it's always, then you can assume it's sample standard deviation and you go to the T. They they need to, if they now said in this question, and I'm glad you asked that, because if I said assume a standard deviation of 4.4 days, then because of that sample size, I don't know if it is a population standard deviation. And then you need to make the assumption that you're working with a sample. And that sample is when very small, then you would have gone for a T. Okay, so, but whenever they tell you population, then you're happy. Then you're actually very happy and you just continue. Okay, so let's look at question 21. Okay, so consider this. They give us, so let's first, we need to work out a critical value. So let's work out, so it's 1, 2, 3, 4, 5, 1, 2, 3, 4. Okay, so that was actually the 5 minus 1, 4 minus 1, which is 4 minus, is 12. Work that, so we could actually have used 21.026. Okay. 21.026. Okay, so 21.026 is bigger than your t-stat. Okay, so 21.026 is bigger than 20 point. So let's just say that your critical is bigger than t. That's so that this is nearly what you then can remember is this component. So if critical value is bigger than your t-stat, so critical value is lying outside, we do not reject the null hypothesis. We do not reject the null hypothesis, or we could have said we accept the alternative. Do not reject, let me just say, do not reject the null hypothesis. Sorry, is exactly the same to say we accept the null hypothesis. Okay, so I would normally just have said, well, critical value bigger than that, I accept the null hypothesis. That's how my mind is framed. So I would have first looked at accept null hypothesis. Ugh. And I'm looking, okay, so accept means I do not reject. So reject, not that one. Do not reject. Ooh, okay, now we're working with two. That's do not reject. Okay, there's always enough information. So let's do not reject the null hypothesis and conclude that country of origin and visa types are not independent. Do not reject null hypothesis and conclude that country of origin are independent. Okay, so there they bring in just that H0 is always talking about the independence. Alternative is always talking about dependent or not independent. And so just remember, now they brought back the two hypotheses. So critical value bigger than T stat, that I always see it as then the T stat is lying within that number. I'm happy, I accept the null hypothesis, but other way to say it is I do not reject the null hypothesis. Okay, that one we did last time. Oh, this one was the interesting one that we needed, but I needed to get the formula sheet for that. So where did I now save that formula sheet? Let me quickly check. Once again, I can't remember all of this. Where did I think I did share it with you guys at the stage as well? Yes, got it. Let's quickly see if that formula is on here. Okay, so that's the mean. That one. I think what I would have used is that formula, which might have been, now I'm worried that it's not one of those, so let's quickly see. There's another one. This is T1. Okay, this is quite interesting. Okay, so there's your expected. So let's just quickly do this. So if you just divided those two, which is not right. So that is, so if you did that, you would have gotten that one. So that is not correct. So this formula is not, so I just want to quickly check where is that formula. SST one with that. Very interesting. Where is which formula I would use here. How did you guys do this? I'm now just, yeah, okay, so it's a sum of that, yes. Okay, but that gives you 0.38. Or did I now work it out wrongly? So I also have it as, okay, yes, because, okay, so what they thank you. Okay, so we've got this. So it is because that is the error component. So it's 1 minus that. So we're getting, okay, thank you very much. I was now really wondering if that makes sense. Okay. So sure, where is that on? I just want to see on the that what I shared. Do you have a reference of that formula somewhere that I can just share it with the rest of the with everyone that we just have that, please? Um, Even if you take a photo of it and share it on the WhatsApp group, it will be great that we just get that formula so that everyone has it. Um, and again, then you can write it down on your notes. Also, just want to check. So, what they could have now done is, I just want to check the square root. Okay, so they haven't. So, again, they could have asked for work out correlation coefficient, so that if you have r square, you can go to the square root of that. Okay, so they didn't, but that is what they could have done as well, is to give you this information, but then ask you to calculate the value of R. Okay, so just remember also that link from R or coefficient of determination to correlation coefficient as well. Okay, that is then that exam paper. So what we're going to do on Saturday. So we're going to have a session on Saturday. Just want to see where I've saved the other exam paper. So I will share it on the WhatsApp group again. But we will on Saturday morning at around 9 o'clock. So I will just reschedule this one to Saturday, so that we can just get enough practice in before you write next week. So Saturday morning at 9 we will have the session again, and then there was that other paper that I shared on the WhatsApp group. I will just share it again, and then we will focus on that one. Yeah, I will also look for just this official one. I think as it's written a bit differently on the formulas that I've shared. So yeah, so I will just go and check from the original formulas. Um, it is there, but it's written differently because so that is already the mean. So where they say the sum of something divided by, that is actually you work out the mean. So I will go and just find that formula that you have it. Um, cool. Okay, guys. So that is it. I will share a recording. I'll share this updated that we've done. I'll share the Excel spreadsheet with you on WhatsApp. I'll load it onto my Unisa as well. Then Saturday we have another session, and then next week we will have another session as well. So there, yes. So there is just so many questions that they can ask. So there is a likelihood that the no, I don't have any idea how the paper looks like. I unfortunately don't get access to that at all. So they do recycle questions, and because it is two or three different types or questions per question nearly, it is that they can recycle a lot of the previous exam papers or even assignments, because they just change the order of some of the answers. Um, yeah, so that does happen. There's a hand, so please, Sabuna, you can please ask if there's a question.
Good evening, sir. No, my question is regard with my WhatsApp request last week. I don't know whether you received my email with regards to 1501, because I wanted to know the differences between the 1501 and the
So
1610.
yes,
Yes.
so what I saw, there's a lot of similarity. I just don't. Do you have? When are you writing that?
I'm writing that on the 18th of November.
Do you have any previous assignments or anything like that you can share with me as well? Um, or was it also multiple choice? Um, because it looks very similar. If I look at all the content, it is really very similar to what you are writing. But I don't want to. So if you can just send me one of your